Hello, class. This is going to be part two of the 10.5 video. 10.5 is volume and surface area. Part one was the volume. This is going to be part two, the surface area. This is going to be a relatively short video, in part because we're not going to be dealing with as complicated figures for the surface area as we might with volume and area. And another reason the book we're currently using didn't have as many like surface area problems, but like the variety as the old book had. So unfortunately, I can't give you as many problems as I would like there. So most of the 10.5 homework deals with volume, but we're going to do a couple quick basic surface area problems and then a couple of word problems. So I'm on page 7 in the chapter 10 handout. But just as a reminder, the formulas are on the formula sheet. And so for the surface area, so we're dealing with a rectangular box. And I'm gonna explain this formula after I give them all to you. So the surface area of a box is 2 times length times width plus 2 times length times height plus 2 times height times width. Again, I'll explain all these. The sphere, surface area for a sphere is 4 pi r squared. I do want to point out we're talking area, so we're back to squared on the radius. If you want to know the connection between the volume and the sphere, the area, again, that's a calculus topic. It's kind of neat how those are actually related, but let's be on the scope of this class. For a cube, it's square that should be cubed. The reason that's 6 times side, that's S for side, because on a cube, all 6 faces are the same. So anytime I use a box, I tend to use this formula, but for a cube, you can do it a little bit quicker. And then the only other shape we're going to talk about is a cylinder, 2 pi r squared plus 2 pi r h. And so again, the first thing I'm going to do is kind of explain where these formulas come from. Not that you need to know or are going to be tested on it, but I think it makes it a little bit more interesting if these aren't just magic. And then once I explain those, then we'll get into the actual problems. So let's start with a rectangle. Why is the formula of a rectangle for surface area 2 times length times width plus 2 times length times height plus 2 times height times width? So let's look at a box, rectangular box. Trying to be brave and draw this in pen. Okay, so for any rectangular box, typically the front, the length and the width, again, those are totally interchangeable. Technical height's the vertical height, but again, remember, we can rotate this however we want. So on a box, length, width, and height is all interchangeable. So if we want the surface area, how do we get the surface area? Well, first of all, how many sides are there in a box? And when we talk about sides on a three-dimensional object, we're talking about, particularly if it's squares and rectangles, the geometry term for that is a face. Okay, so how many faces or sides are there on a box? Well, there are 6. We have the front and the back, top and the bottom, and then the sides, the left and the right. And the nice thing about a box is the front and the back are the same size, top and the bottom are the same size, and the left and right are the same size. So if I want the surface area, let's look at the top and the bottom. Well, if we're looking at the top, well, actually, let's look at the bottom. I think it'll feature. So let's look at the bottom. So how do we get the area? Surface area is the outside area of the box. So what is the area of that bottom? Well, it's length times width. So that's for the bottom. The top is the same thing. So we can just do twice that. And so that, and for my rectangle, length and width, it's top and the bottom. Okay. Now let's look at the sides. Okay, so for the sides, okay, so there's the right side. And so what is the area of that side? Well, that is width times height, and there's a left and a right, so there's two of them. So, and it doesn't matter if you do height times width or width times height. So we did the top and the bottom, left and right, so now let's do the front and the back. Another color. So if I want, let's say the front. So how do we get the area of the front? Well, that's length, and then that is going to be height. So it's H times L, and there's two of them, front and the back. So that is where this formula is coming from. 2 times length times, so if you notice length and width, length and height, and then width is with length and width is with height. So basically that formula is just getting us the area of the top and the bottom, the both sides, and the front and the back. So when you're doing this, just make sure that, like length goes with width and length goes with height. And also the width and the heights have to go together as well. So that's where the formula for the surface area of the box is coming from. You got the 6 sides, and you have some equality some of those sides. Okay. And then if it's a cube, the reason you get S cube, sorry, started off as a bad cube. Let me get this. See if I can make it actually cubic. This is not scale. We're assuming it's a cube. So on a cube, instead of calling it length, width, and height, we tend to call it S for this side. Okay, so if all of those are S, where do we get the surface area is 6 times S cubed? Well, that's because the length and the width are the same. So that would be S times S. Oh, why am I doing cubed? Sorry, I'm ready for lunch. That the squared was right because we're talking area, not volume. Okay, so S times S is going to give us S squared. So there's 2S squared. Up here, width and height is S times S. So that's another 2S squared. And here, height and length are S and S. So that's another 2S squared. So 2S squared plus 2S squared plus 2S squared is 6S squared. On a cube, cubes and squares are, just special types of boxes. If you don't remember that formula, you can treat it just like a box, a regular rectangular box, and you'll be fine. All right. So the other fun one I think here is that I can explain without calculus is the cylinder. Let's see, I've drawn most my cylinders up and down, so let's draw one sideways just for fun. Excuse me. So that is our height. Height doesn't matter if it's a horizontal height or vertical height. And then the other thing we need is the radius. So those are the only 2 measures that you need. Because the formula for surface area of a cylinder is where it's 2 pi r squared plus 2 pi rh. So where does that come from? Okay, well, for a cylinder, again, surface area is the outside. So what do you have on the outside? Well, on the top and the bottom or the ends, those are circles. Right? So what's the formula for the area of a circle? It's pi r squared. And we have 2 of them because we have, the top and the bottom, or the left and the right. So that's where the 2 pi r squared is coming from, is the 2 areas of the circle, areas of the 2 circles. Now, this 2 pi rh, this is the area of the body of the cylinder. Well, where is that coming from? Well, how do you get a cylinder? Oh, sorry, let's see. I'm trying to figure out how to do this on camera. If you take a piece of paper, let me go to my other camera. Let's see, how do I get to? All right, so used to going back and forth between screens, now I don't know how to get it off the screen. Okay, well, here it is. All right. Well, sorry, I can't get over to, I don't know how to unshare it from the screen. So, but basically take a piece of paper and roll it up. That's how you get a cylinder, right? Because, because on the end, obviously this is horrible on the document camera, I apologize. So there, if you roll that up, you have a cylinder. And then so, the top and the bottom are circles. And so we got the area from just a circle. And so, but if the outside is a rectangle, how do you find the width or the area of a rectangle? Well, an area is length times width or base times height. Well, we know that one side of, this side is h, but what's the the width? The width is a circle. So we're actually, the width of this rectangle is the circumference of the circle. Like however big that circle is, when you fold it out, that's going to be the width. And how do you find the circumference of a circle? Well, circumference of a circle is 2 pi r. So that 2 pi r, that is how big, or that's the width of the rectangle when you fold this out. The height would be the length. Again, you don't have to know where these come from, but these aren't just random. It's the area of each piece. All right. So a little bit of side information there. So now let's actually do some calculations. Let's find the surface area of this rectangle. Leave my camera around. All right. So we've got a rectangular box, the surface area is twice the length times the height plus twice. Now, it doesn't really matter the order, but since I had L first, I want to do L and W. And then without L, I need H and W. Again, the order doesn't matter as long as you get all three pairs. And it helps if you label. So that way, when you're setting up your formula, you put the numbers in correctly. So it's going to be twice length times the height. So 4 times 3. Plus twice the length times the width. So 4 times 7. Plus twice the height times the width. So 3 times 7. So I've got 4 times 3, 4 times 7, and then 3 times 7. From there, it's just arithmetic in a calculator. 2 times 4 times 3. We'll do this separately. 56. And then 6 times 7 is 42. And then add all those up. So I'm getting 122. Now, what are the units? So here's where, don't forget, we're talking area. So area is always squared, and we're talking meters, so that would be meters squared. So the outside of that rectangular box is 122 square meters. Okay. I mean, like I said, for surface area, we're not going to do compound figures like we had like the ice cream cone. We're going to keep it pretty basic. If you want the area of that cube, you could do length times what, we could use this, or since it's a cube, you could use the quicker version of 6s squared, where s is that side. So that would just be 6 times 10 squared. Be 600 dealing with feet, so feet squared. If you did the above formula, you'd have length and height would be 10 times 10. So that would be 100. So that would be 200 for that. Length times width, it would be 10 times 10, which is 100. So that would be another 200. And then height times width would be another 10 times 10. So another 100, two of them. So that'd be 200 plus 200 plus 200, which is the 600. So when in doubt with boxes, this is the formula you really need to know. This can be a little bit shorter if you have a cube. All right, what if we have a sphere? How do we find the surface area of a sphere? Again, you don't have to memorize the formulas, you just know how to use them. So surface area of a sphere is 4 pi r squared. Now, what is pi? Well, here we have to be careful. That's all the way across. That 9 is the diameter, not the radius. So the radius is half of that. So half of 9 is 4.5 inches. All right. I don't remember if they're doing the pi thing on this, so let's just let's do this in 2 steps just in case. Like we talked about with earlier examples, sometimes they want in terms of pi and then approximate answer. So if we're doing in terms of pi, 4 times pi times 4.5 squared squared, it's 4. So that would be 81 pi. Now, what are the units? We're dealing with inches, we're talking area, so it'd be inches squared. So that would be in terms of pi. And then if we want the approximate value, we're going to do, then we plug in pi is 3.14. So 254. 134 inches squared. And then, as always with MATLAB on these problems, look, since we have a decimal answer, look to see if they want you to round. They want the nearest whole number be 254, or nearest tenth would be 254.3. Nearest hundredth, well, there's only 2 decimal places to see when we're at. So again, like I said, we're not getting too complicated with this. So, all right. How about the surface area of a cylinder? Well, surface area of a cylinder is 2 pi r squared plus 2 pi r h. So what is the 7? 7 is the length, so that's the height. What is the 2? That's all the way across. So that's the diameter, which tells us the radius is half of that. So that's 1 foot. That's going to be a nice number to plug in. So again, let's do this 2 steps. One where we just do it in terms of pi, and then we'll plug in pi is 3.1. So surface area is 2 times pi times radius squared, which is 1, plus 2 times pi times radius, which is 1, and height, which is 7. And remember, for this first part, we're not plugging in pi yet. Well, 1 squared is just 1, so that would be 2 pi. So that would be 7 times 2, so it'd be 14 pi. So it'd be 16 pi. And what are the units? We're dealing with feet, and we're dealing with area, so it'd be feet squared. In terms of pi, it would be 16 pi square feet. And then the approximate answer, now would plug in pi 3.14. Is 50.24 square feet. Or 50 feet, square feet if they wanted it to the nearest whole number, or 50.2 if they wanted to the nearest 10. Okay, so like I said, surface area, we're gonna give you a figure. We're not gonna make it a compound figure. That's pretty straightforward. There are a couple of word problems in the homework associated with this. But again, don't forget, and that's supposed to be S squared right in the first place. You have your formulas for the area, all your surface area formulas. You just need to know how to use them. All right, so let's jump into the homework and see those couple of word problems I was talking about. So I think these are the last two from, so this is the 10.5 homework. So this is number 23. So Mac is about to sue his contractor who promised to install a water tank that holds 3,280 gallons of water. Mac knows that 3,280 gallons is the capacity of a tank that holds 439 cubic feet. Yeah. So they've already kind of done, so basically sounds like he's done the conversion of converting cubic feet to gallons. All right. So the cylindrical tank, so we're dealing with a cylinder, has a radius. Let's see. So is this a surface area or is this a volume problem? So they give us the radius. So let's see. Does evidence? Okay, here. So we're talking cubic feet. That's cubic. So that is not a surface area problem. Okay, that's a volume problem. So how do we figure that out? Well, basically all you do is you got a formula for the volume of the cylinder, and then you would plug that in, and go from there. I'm going to skip this one because we're doing surface area. Oh, never mind. Both of those questions are volume problems because on this one it's 2 cans of soup. Which one's the better buy? Well, for there, you just find the volume of each one of those, and then see which one's bigger. Now, I will say that, so since the volume formula for a cylinder is pi r squared h, the issue here, let's see, is like, nope, there is no issue. So just make sure that when you're dealing with each can, draw it out. So one can has a diameter of 7 inches, a height of 5 inches. So draw that. The other one has, so the only thing here is make sure that you go to radius. So there's not even any word problem on surface area. It's just, here's a couple of objects. Oh, I knew there was one in the homework I needed to talk about. Okay, so this one, this is not a shape that we have. So let's make sure we can find. It's not a word problem, but I knew there was at least one in the homework I needed. So find the surface area of this figure. So this is number 19. While you're looking at that, I've drawn it on my paper and then we'll discuss. So it's sort of a theme on all our units so far that there was at least one more complicated problem, if not 2 or 3. So this is sort of the complicated surface area problem. So how do we walk through that? All right, so in this case, we have, this is what we would call a prism. So it's not a rectangular box. If we were doing the volume, I'm missing a measurement. The volume would be like the area times the height, but we're doing surface area. So here's the question. How many sides, how many faces do we have? Well, we have a top and a bottom. We have the front. We have the back left. And we have the back right. So we have the front here. On the back left, we've got that. And on the back right, we've got that piece. Okay, so let's kind of go through like section by section. Let's start with the top and the bottom. All right, so if we look at the top, what shape are we dealing with? We're dealing with a triangle, especially that we know that this is 9 centimeters, this is 12 centimeters. So what shape do we have? We have a triangle. So what's the formula for the area of a triangle? If you don't remember, it is area is 1/2 base times height. Does it really matter which one's base and height? No. It may look weird because like normally we would like say that we would put the base down here and then draw up. But since these are perpendicular to each other, one of those is the base, one of those is the height, it doesn't really matter. So I'm just going to call this one the base and that one the height. The area is 1/2 times 9 times 12. So that is what, 6 times 9, so that's 54 centimeters squared, because we're dealing with area. Now there are two. So we're going to multiply this times 2. So that would be 108 centimeters squared. So this is the top and bottom. So that takes care of one piece. So how about the front? And we'll be running out of area on these. All right, so for the front, let's draw that. Ooh, this is a fun one. Okay, so let's look at the front here. So what do we know about the front? Well, we know that's 18 centimeters. Do we know the width? Okay. So if we come up here, the width has not been given. So how do we find the width? Well, notice that we're dealing with a right triangle and we don't know one of the sides. So how do we find the length of a missing side of a right triangle? This goes all the way back to first thing we did in chapter 10, Pythagorean theorem. A squared plus b squared equals c squared. All right, so this is a good problem from a math teacher's perspective. All right, all sorts of critical thinking going on here. So remember from hopefully you've done your Pythagorean theorem homework. So we need to figure out what are we missing? Well, the one opposite the 90 degrees is always the C. So we don't know C in this case. The A and the B are the two that make up the 90 degrees. It doesn't really matter which one's which, but those two are A and B. What we don't know here is C. We have 9 squared plus 12 squared equals C squared. So that's 81 plus 144. 144 plus 81 gives us 225. Now remember that's C squared, not C. So at this point, we need to take the square root of both sides. It's the square cancel out. And then the square root of 225 is 15. So we now know that that side is 15 centimeters. So now how do we find the area of the front? This is just a rectangle, so it's length times width. So it's 15 times 18. And what is that? So 270 square centimeters. All right, so we had to do a little bit of work there just to get the area of the front. So that is 2 or 3 of the sides. We got 2 more. So let's do this back left. So again, this is where I like to redraw these. And I'm going to kind of keep it in the same orientation. Yeah, that's I'm trying to keep that same orientation that I was drawing here. That helps me. And so what do I know? I know that that is 9 centimeters. That was given. Now, what is the vertical height? That is the 18 centimeters. So we don't have any weird things. We don't need Pythagorean theorem on this because we know both our sides. So area is just length times width. Or base times height, or however you want to say it. It's just 18 times 9. We get 162. We're still dealing with square centimeters. And then the back right. So the back right is going to be that shape. So let's draw that rectangle. It's going to look like another parallelogram. keep the orientation the same. All right, so what do we know? We know that's 18 centimeters high. And then from the pyramid, or from the original, the prism, it's going to be 12 centimeters. So maybe it's a little cocked, but that's a rectangle. And so we're just doing areas length times width. 12 times 18. But 216 square centimeters. So the total surface area, let's just add all those up. So from the top and the bottom, we had 108. In the front, we had 270, 162, and 216. So the total surface area is 756. And again, we're still talking area. So 756 square centimeters. All right, that was more fun than I expected. Okay. So, but the key here is we're dealing with a three-dimensional object. We want the surface area, so we want all the outside areas. The top and the bottom were the same, and they're triangles. So we found the area of one triangle, and then multiplied it by 2 to get the top and the bottom. On this one, on the front rectangle, we didn't know the width, but since that was a right triangle, we could use the Pythagorean theorem. And then that was the hypotenuse of it. So, we solved for C. Once we did that, then it was a straightforward calculation. And then the back left and the back right, we just had to be careful on getting our dimensions. So there's not very many surface area problems in the homework. This is the sort of, this is definitely the top end. Most of the rest of them are just very straightforward. Here's an object, calculate the surface area. All right, that is it. So, and that is all the topics for this for chapter 10. So the only other video for this class I have to put out will be the test review. So have fun with this, and I'll see you for the test review video.